in about equal proportions, we produce a color change that is unusual, and you'll see why. Okay, so watch it carefully. It starts clear. Hopefully it happens. There we go. So what's unusual about this is it goes back. So that's why it's called an oscillating clock. If we back to clear, right? Most things change in one direction, but this chemical reaction kind of toggles back and forth. And it'll keep doing that for a while. Alright, so let's try this. I've never actually done this one. We'll see how it goes.
What is this, for toothpaste?
So I believe that this one, if you shake it, it changes color. Maybe it won't work. Sometimes chemistry doesn't work. Let's try this one.
It's just the starting condition.
What's that?
It's just not the starting condition.
Yep.
Chemistry always works.
Chemistry always works. The chemicals don't always behave. Okay, let's try this one.
Oh no!
All right, maybe they're not going to behave. What's that? Oh, we'll come back to that. All right. Okay, let's see what else we got. This is kind of a cool one. Some of you might have heard of like redox reactions.
I hope they do after toothpaste.
Okay, so this is iodine. You use it probably as like an antiseptic for cuts and stuff. I can put it on my skin. It makes my skin turn brown. And if you change what's called the redox status of iodine, it will change colors. Okay, this is starch. So this is something you all have in your medicine cabinet, probably vitamin C. Vitamin C is an antioxidant, so it will reduce what's on my arm and hopefully change color.
Ooh.
I'm not just wiping it off, that's actually changing the redox state of iodine back to something that's going to look good. Okay.
Can you just get him in this and
Okay, another thing that we take advantage of in chemistry, and sometimes, let's see, where's the liquid nitrogen? I'm good. Okay. So with chemistry, we take advantage of temperature changes. Sometimes temperature changes can be an indication that a reaction's happening. Sometimes it's something we would use to make a reaction happen. So I'm going to take liquid nitrogen here, which is, what's the temperature of liquid nitrogen? It's around -300 or 400 Fahrenheit, I think. You know, if you get it on your skin, it burns you. You've probably been to that ice cream place where they make ice cream with it. So within this balloon, there's air, right? Someone breathed into this balloon. The molecules in air expand when you breathe into a balloon at room temperature. But if you chill those molecules, what's going to happen? It's going to shrink, like they're going to get closer together. So let's see what happens if we make them cold. Okay, so there's still air in there. The same number of molecules are inside the balloon. Here, touch it. You can heat it up with your skin. You know, you can make it heat up quickly just by touching it. In fact, so again, the molecules, there's still the same number of molecules inside there. You're just making them cold and packed together more tightly.
if only we were seeing
Anyone want to touch it? Do that.
that's me.
There we go. That liquid, a little bit of liquid nitrogen on your skin can cause problems. Okay. All right.
Can we go back to the point?
Let's try this color. Like someone said, chemistry always works. Sometimes you shake it for a while. All right, so you've probably seen this one too. There's a BYU graduate on YouTube that has done this on a very, very large scale. This is called elephant's toothpaste. And speaking of chemical reactions that change temperature, this one actually produces heat. So let's see what happens. So, got a little bit of something in the tube. We've got some potassium iodide here. And this is a pretty violent reaction. And this is just a tiny bit of chemical that we've reacted. And you can see the heat coming off, right? The steam. So check YouTube out. The guy did it on like an enormous scale. And it was really
Mark Rober?
Mark Rober. This is the big one that. So I'm gonna hold this and
So Nathan, if you can grab the wire. Yeah.
it's gonna get a bit dark.
So it's gonna get dark here. We're going to, you've all seen those like glow sticks that you crack. The cracking mixes chemicals that then glow. This is similar to that. This is called luminol. Two chemicals, by themselves, they're completely boring and just clear, but together, they change color. They glow. Okay. Want to grab the lights? Okay, this is fine. Hopefully this is heated up enough. Well, let's let that go. Okay, so also in chemistry we take advantage of phase changes in phase, which could be things turning solid from liquid to solid or solid to liquid. We see this all the time. The chemistry of phase change. We see blood clotting. If you leave milk in the fridge too long, it changes phase. It goes from liquid to solid, right? You've all seen that. You can also take advantage of chemistry and this kind of phase change to create nylon. So we've got two liquids here. When we pour them together, it creates a polymer that you can then turn into basically a rope and weave into clothes. And a lot of you probably have nylon clothes on. Let's try this out. This one is one you do not want to touch. And it's somewhat flammable. You don't want to get the fire started. Alright. So I mixed them together. They were totally liquid. Let's see. There we go. Alright. And the reaction is happening right at the surface. So as we pull nylon out of solution, new liquid reacts and forms that nylon polymer, and we can just keep winding it up.
But that's very far away. That is just liquid in the bottle.
Yeah. And so I wouldn't want to touch this with my bare hands at this point until it's dry, but you can. This is a pretty sturdy nylon rope. All right. What about do we have sodium acetate?
Clear one.
Oh yeah. Okay. This is a cool one. All right. So I want to show you up close, as close as I can get. So this is a solution of a salt that is just on the verge of crystallizing. And all we have to do, in fact, if I just shake it a little bit too much, sometimes it kind of crystallizes and turns into a salt. But all I gotta do is just tip the balance a little bit by adding a little more sodium acetate, and watch what happens. Whoa. Okay. So it formed these crystalline type bonds between the molecules, and it's completely solid. If you go out to like the salt flats, that salt you see is kind of a similar form. Okay.
Just keep it warm.